The idea of a revolving universe can be developed into a scientific model based on well-established physical theory and knowledge.
The idea that there could even be a way of proving through experimental observation that there could be absolute gravity is just wonderful.
Our first presenter this morning is George Park. George has presented in the two previous scientific symposia. Thank you for your faithful and thoughtful participation, George. Today, George's talk is titled A New Model of the Universe. Welcome, George. The platform is yours.
Thank you, Marjorie. Good morning, everyone. Today, I'm going to talk about how the cosmology in the Urantia Book can be coordinated with scientific knowledge in a new model of the universe. So why do we need a model? Well, the purpose of a cosmological model is because we have an irresistible need to explain what we observe in the heavens. And the Urantia Book describes a revolving universe, but that's never been observed. So from an evolutionary perspective, there's no apparent need for a revolving model of the universe. The current expanding model fulfills the need to explain Hubble's discovery that galactic redshifts increase in proportion to distance due to space expansion. But the book tells us this space expansion explanation is wrong. However, this relation can be explained by a revolving model developed from key ideas in the book. And this revolving model emerges in an evolutionary manner from the history of Western thought, of which there have been 6 consensus models, more or less, in Western cosmology, starting with the geocentric model. And the current model is now the centerless expanding model, proposed by Alexander Friedman in 1924, based on Einstein's general relativity. This model didn't really become effective until Hubble's discovery in 1929 of the redshift distance relation. So the next model, I surmise, will be based on the idea of a revolving universe, which originates with the Urantia Book. So modern cosmology really begins with Hubble's discovery of the redshift distance relation in 1929. He found it by measuring redshifts and distances to 24 galaxies, and he found the linear relation shown in the graph on this slide. This is from his 1929 paper. He interpreted this in terms of velocity, since velocity causes redshift, and it's equal to the velocity divided by the speed of light. So this is called the Hubble constant, which is part of the velocity distance law. So space expansion is the cause of these receding velocities. Since the space expansion of Friedman's model appeared to be the only way to explain the redshift distance relation, it was generally assumed that space expansion must be real. But a number of prominent scientists pointed out, including Hubble, that it needed to be verified. But the overall results from many implementations of different tests for the reality of space expansion are still inconclusive. I have something more to say about this at the end. So as things stand, the universe could be either static or expanding. And it's noteworthy that Hubble changed his mind about space expansion. He eventually, for a number of reasons, came to reject it, even though there was no other apparent explanation for it. He concluded there must be some new principle of nature which explains this relation he had discovered. And he was onto something, because a perfecter of wisdom acknowledges that receding velocity causes redshift, and he even cites Hubble's constant of 100 miles per second per million light years, which he gives in his Realm of the Nebula he published in 1936. But he then states this apparent speed of recession is not real. The redshift distance relation is not explained by receding velocity. Galaxies are not receding due to space expansion. And in the next paragraph, he says the primary cause of these redshifts is a time-space distortion, which involves the space levels which revolve around paradise. But he does not elaborate on what this time-space distortion is. So if we look to conventional astrophysics, there are three possible causes of redshifts in galactic redshifts. Cosmological redshift is caused by the receding velocity of space expansion. Doppler redshift is caused by a receding velocity. And gravitational redshift is caused by gravitational potential. So galaxies are not receding. So the only possible candidate here is gravitational redshift. And this type of redshift is an effect of gravitational time dilation, which is described by general relativity. It's caused by a difference in gravitational potential between two locations. The time dilation is counterintuitive. It's a slowing down of time. Time passes more slowly for an event occurring in a stronger gravitational potential when it is measured from a weaker gravitational potential. The effect of time dilation is like viewing a recorded event in slow motion instead of normal motion. The more time is dilated, the more time we observe it takes for the remote event to occur. And time dilation results in redshift because the frequency of light decreases as time slows down. For example, light from the sun is redshifted by about 2 parts in a million because the gravitational potential on the sun's surface is stronger than the gravitational potential on the Earth's surface. So gravitational time dilation can be fairly described as a time-space distortion. There is a problem with this idea, though. Gravitational potential weakens as distance increases. So light would be blue shifted instead of red shifted. So this explanation would not be viable, except for the fact that the book says there are 2 forms of gravity. Linear or local gravity is Newton's gravity, and gravitational potential weakens with distance because acceleration is inversely proportional to the square of the distance. But the gravitational potential of absolute or paradise gravity increases with distance because acceleration is proportional to distance. So this idea about absolute gravity comes from the Perfecter of Wisdom, who compares it to the force of an elastic tension, which is described by Hooke's law. Under this law, the force of elastic tension equals a force constant times the distance of displacement from a fixed position of equilibrium, which would be paradise in this analogy. So under absolute gravity, gravitational potential strengthens as the distance from paradise increases, so the light from distant galaxies would be increasingly redshifted as distance increases. Now, this behavior of absolute gravity appears to be revealed because it is so unlike linear gravity. And in a paper I presented at the last symposium on absolute gravity, I argued this law can be reasonably inferred from the available evidence. But reasonable inferences can be wrong. For example, the inference that space expansion causes galactic redshifts is reasonable but incorrect. So a more certain and solid foundation for this law was eventually found in Newton's Principia. Newton had doubts about gravity, which led to his discovery of two forms of the law of gravity. His doubts revolved around his solution to Kepler's laws. He could prove Kepler's laws of planetary motion are explained by an inverse square force, but he was not certain this force held everywhere, such as near the surface of a celestial body. He resolves these doubts with a series of remarkable geometric proofs, which demonstrate that outside a celestial body, gravity varies inversely with the square of the distance. But inside a celestial body, gravity varies directly with the distance. The geometric proofs leading to this discovery constitute his shell theorem. Now, this is more just to give you an idea of how complex the shell theorem derivation is. These are the three geometric instructions. The first one is not too difficult. It just says a point in the middle, anywhere inside a hollow sphere, experiences no net force. It's like there's no gravity. The next, proposition 71, proves that a particle outside a hollow shell is attracted toward the center inversely according to the distance, the square of the distance. And this holds also for a particle outside a solid sphere. Proposition 72 is the surprising one. It says that a particle at some point inside a solid sphere is attracted by a centripetal force that is proportional to the distance. In other words, it's very different from being inversely proportional to the square of the distance. So the relationships between these geometric proofs can be more readily seen by deriving the equation for internal gravity from the external equation. So that's just what this slide shows. It shows the internal equation and then substituting the total mass of the celestial body for a formula for the mass based on the volume times the mass density, and substituting that demonstrates that internal gravity causes acceleration to increase in proportion to distance. So at the surface, the acceleration of both forms is the same because mass and distance are the same. So we can show this relationship graphically on the next slide, because gravity is measured by acceleration. So on the left portion of this slide, you can see that acceleration increases in direct proportion to distance within the solid sphere, but from the surface outwards, acceleration is inversely proportional to the square of the distance. And the key point of this slide is that the equation for external gravity is only valid from the surface of the body out to infinity. And the equation for internal gravity is only valid from the center of a body out to its surface. So absolute gravity is obviously equivalent to internal gravity, which Newton proves is as real as linear gravity. What we're referring to here is external gravity, because both can be described by the force of elastic tension, and both are instantaneous. Both absolute gravity and internal gravity are related to linear gravity. So we can say, to the extent that science can be certain about anything, it's certain that the laws of absolute and internal gravity are equivalent. So this has cosmological significance because a premier postulate of modern cosmology is the universe is finite and has a uniform mass density. And this postulate is consistent with the internal form of gravity, which applies within any finite sphere with a uniform mass density. And under Newtonian theory, gravitational potential is equal to acceleration times the radius. So multiplying the internal equation for acceleration by the radius gives the gravitational potential for internal gravity. Now, from this equation, you can see the gravitational potential increases in strength with distance. So gravitational time dilation and gravitational redshift also increase with distance. Last fall, I published a scientific paper which explains the redshift distance relation in terms of the internal form of gravity. So this paper reviewed the Friedmann expanding model explanation for galactic redshifts and an equivalent Newtonian expanding model proposed by Edward A. Milne. It then develops a static universe model from Milne's model, which explains galactic redshifts. So cosmological redshift in the Friedmann model is based on the idea that it takes time for light from a distant galaxy to reach us. And during the travel time of light, space expansion causes the galaxy to recede from the proper distance r, where it emitted light, to the so-called co-moving distance d, where it is now. And cosmological redshift is actually determined by the ratio of co-moving distance over proper distance, which is called the scale factor. The velocity distance law gives the galaxy's velocity now at its co-moving distance. And in this model, in this model, velocity is directly proportional to co-moving distance. So that's a pretty simple overview of it. And this model has a defining equation which describes a universe of curved expanding spacetime. But it's been determined over the last several decades that spacetime is not curved. It's actually flat, and it's like the space of Euclidean geometry. So Friedmann's equation can be simplified to what's called a critical density equation, which applies for flat expanding spacetime. In flat spacetime, the Hubble constant squared is proportional to the uniform mass density. And conceptually, the Hubble constant squared represents the energy of space expansion initiated by some Big Bang, and the right-hand side represents the energy of space contraction due to Einstein's gravity. So just for reference, a recent value for the Hubble constant is 73 kilometers per second per megaparsec. And the uniform mass density calculated from this is 10 to the minus 26 kilograms per meter cubed, which is equivalent to about 6 hydrogen atoms. So in 1934, Edward A. Milne proposed an alternative explanation for the redshift distance relation that does not rely on the hypothesis of space expansion. Instead, in his Newtonian expanding model, a sphere of matter expands in static Euclidean space. So in Milne's model, galactic redshifts are Doppler redshifts, and these occur when light is emitted. Doppler redshift equals the receding velocity of the galaxy over the speed of light. And the velocity distance law gives the past velocity of the galaxy at the proper distance it was when it emitted the light. So substituting CZ for velocity in this law gives the redshift distance relation. So redshift over proper distance equals the Hubble constant over the speed of light, which demonstrates that matter expansion instead of space expansion leads to the same result. And Milne goes further, and he proves this model is equivalent to the space expansion model by deriving Friedmann's equation from Newtonian theory. And he begins with the Newtonian equation for the total energy of a gravitational system. And then he works down through a series of steps. In step 5, he derives the Friedmann equation. So the redshift distance relation can be explained by internal gravity, as well as by space expansion. A Milne's expanding model becomes a static model if receding velocities are apparent and not real. So the gravitational potential equation in Milne's model of the square of the receding velocity. But in this static model, v squared is not a velocity, it's the energy of the gravitational potential at a distance from the center. So in Milne's model, the receding velocity is derived from the Doppler equation. So squaring both sides of this, the energy of the gravitational potential equals c squared times z squared. So substituting that for v squared in Milne's gravitational potential equation gives the static model equation for both gravitational redshift and the redshift distance relation. So the term under the first square root sign is the term in general relativity, which determines the gravitational time dilation, which causes gravitational redshift. And the term under the second square root sign is the right-hand side of the critical density equation, divided by the square of the speed of light. And this gives Hubble's linear redshift distance relation. So this static model can explain gravitational redshift, which is an effect of gravitational time dilation. And under internal gravity, this redshift equals the ratio of dilated time over the undilated time minus 1. So time dilation can be added to the previous equation since it equals the gravitational redshift. And rearranging the first equality shows there is a linear redshift time dilation relation. So the increase in time dilation with redshift means the universe has a temporal structure as well as a spatial structure. I mean, proceeding outward, there are concentric shells of uniformly dilated time. As extraordinary as this conclusion is, the expanding model makes exactly the same prediction. There is a linear relation between cosmological redshift and cosmic time dilation. And this prediction has been empirically confirmed from the light curves of type 1a supernova. The duration of a supernova explosion increases in proportion with its redshift because time dilation causes all physical processes to slow down relative to an observer's time. The static model can explain more. The highly uniform temperature of the cosmic microwave background radiation is interpreted as a secondary body of evidence which substantiates the space expansion interpretation. This is a long explanation, but the model predicts that there's a redshift temperature relation in this model. The CMB temperature at a redshift Z equals the observed temperature multiplied by 1 plus Z. And this prediction has been empirically confirmed. The static model makes exactly the same prediction. So the static model is a credible alternative to the expanding model because it can explain the same things. So this 2021 paper, which I've been describing, does not address the type of motion the Hubble constant represents in the static model. I mean, in the expanding model, the Hubble constant is the rate of increase in receding velocity divided by a unit distance. So dimensionally, its units can be resolved to 1 divided by a unit of time. Well, it turns out the Hubble constant becomes a universal angular velocity constant in the static model, since angular motion is the only possible universal motion in a static universe. So the Hubble constant, current value of 73 kilometers per second per megaparsec, becomes an angular velocity constant equal to 2.37 times 10 to the minus 18 radians per second. This interpretation of the Hubble constant changes the static model into a static revolving model. And this change to an angular velocity constant necessarily follows from the fact that the force of internal gravity is described by Hooke's law, and this force causes simple harmonic motion. Simple harmonic motion is a type of periodic motion which has a constant frequency determined by a force constant. This constant K in the potential energy equation for simple harmonic motion can be set equal to mass times angular velocity squared. So going through these steps, we wind up demonstrating that the angular velocity squared equals the Hubble constant squared equals the right-hand side of the critical density equation, which proves that the angular velocity constant is equivalent to the Hubble constant. So a system that's governed by simple harmonic motion, the basic equations of motion in it are defined by an angular velocity constant. So that's what this slide is about. And you'll notice down at the bottom of the slide, it talks about orbital period as a function of angular velocity. So for the angular velocity constant identified from the current Hubble constant, all orbits around Paradise have a period of 84.2 billion years. So the idea of a revolving universe can be developed into a scientific model based on well-established physical theory and knowledge. Since the revolving model can explain what the expanding model explains, the more accurate model will be determined by how well each one explains other astronomic observations. The revolving model predicts a rate of rotation, but it's too small to be currently observed. But it presents the dynamic of universal gravitational revolution, which can result in the planar organization of matter on large cosmic scales, because this occurs relative to a universal axis. The vector of the angular momentum of the rotating mass of the universe is along the axis of its rotation, and gravity always acts preferentially in the plane perpendicular to the mass. On the other hand, space expansion causes the universal dispersion of matter from every point in every direction and cannot result in the planar organization of matter on large cosmic scales. In the paper on the law of absolute gravity, I identified two large planar structures which are consistent with the superuniverse and first outer space levels. These are briefly reviewed here, and a third, much larger, planar structure is identified. So at the highest level is the master universe, which consists of 6 superuniverse space levels concentrically arranged around Paradise, which form a plane of creation. And the superuniverse space level is organized around Havona, and it is initially partitioned in 7 stupendous segments, with the headquarters world near the center of each wedge-like segment. Urantia is the headquarters world of Orvanton, our superuniverse. And the distance from Uversa to Paradise is 2.3 times the shortest radius of Orvonton within its wedge-like space segment. Now we're told galaxies in Orvonton orbit Uversa, so we can assume the same occurs in the other 6 superuniverses. And these 7 dense concentrations of galaxies form an elliptical ring in the superuniverse space level. And we can designate the central portion of this ring the central core, and then obviously inner and outer zones relative to that. So in the book, we're told that the Milky Way is the central nucleus of Orvonton. The Milky Way and other galaxies in our superuniverse move as a whole unit with Uversa. I mean, we're told these galaxies are traveling along with us. The Milky Way is part of the local group of galaxies first identified by Hubble in 1936. They're all bound together by gravity and move together as a whole unit. So the local group is the central part of Orvonton, and it has a radius of 4 million light years, plus or minus 500,000. So the distance to Paradise should be 9.2 million light years. And the galaxies in the superuniverse space level should be found within 32 million light years. So this is an all-sky chart showing galaxies at distances between 5 and 32 million light years. It comes from a 2018 query of NASA's extragalactic database and identifies over 5,000 galaxies within this distance. 3,700 of them are concentrated in a belt along the celestial equator. And these galaxies were identified by the 2-degree field galactic redshift survey conducted between 1997 and 2002. The box outlining this belt of galaxies is the survey window used by this 2DF survey. So plotting these in 3 dimensions and looking down on the plane from the North Pole, this polar view of 3,700 galaxies shows them spread out in a fan-like form. And the central core should be somewhere in this fan-like area. And it should become apparent if galaxies where the galactic density is less than some minimum are filtered out of the plot. Think of this filtering out of galaxies. Think of it like taking an X-ray of the data to show where the galactic density is greater. So here's the same picture, except with the outline of the survey area on the equatorial plane shown. And this has no filter. But if we say there have to be at least 10 galaxies per megaparsec where a galaxy is, we get this picture. And you can see a number of galaxies on the left-hand side are no longer plotted. And if we raise this to 25 galaxies per megaparsec, we see more are removed from the left and some from the right. And I'm just going to go through at 40 galaxies, 55 galaxies, 70 galaxies, 85 galaxies per megaparsec cubed. At this density filter level, or at this X-ray, we see a very well-formed arc to the left of the Milky Way. And if we overlay the chart of the grand universe, the superuniverse, on this, we can see it's a very good fit for the central core of the superuniverse space level. It's clearly distinguished from the inner and outer zones. And this is relatively conclusive proof that central core of the superuniverse space level exists. And the center of this dense elliptical ring of galaxies is 9 million light years distance, which is close to the expected distance to paradise. And the density of galaxies within this ring is about 9 times greater than the average density. Now, if we reset the density filter to 20 galaxies per megaparsec cubed, we see there is a good fit between the elliptical outer border of the superuniverse space level and this plot. And the density in the outer zone increases from 20 to 85 galaxies per megaparsec cubed. And then the density in the inner zone decreases from 85 to 20 galaxies per megaparsec cubed. So these complementary density gradients prove beyond a reasonable doubt the existence of the elliptical ring of galaxies, which is the central core. And this can't be explained by the mechanism of space expansion, but it can be explained by internal gravity. So having found what I believe is the superuniverse space level central core, we have a pattern to look for in the first outer space level, which is concentrically arranged on the same plane as the superuniverse space level. It has a central core that's a continuous belt encircling everything. And the central core should appear as a belt behind the 2DF belt of galaxies in an all-sky chart. The center of its central core should be at a distance of about 900 million light years, which would be 100 times the distance in the superuniverse. The Sloan Digital Sky Survey conducted operations starting in 2002, and their first data release was in 2003. And J. Richard Gott discovered the Sloan Great Wall in this first data release. It's a belt of more than 20,000 galaxies that's 1.4 billion light years long, and it's the largest concentration of galaxies within several billion light years. The Sloan Great Wall is too large for the expanding model to explain. Now, if we plot it in 3 dimensions, we can see it forms an arc, and the center of this arc is at 978 million light years, according to Gott. And this is within 10% of the 900 million light years expected. So the Sloan Great Wall is consistent with expectations for a segment of the superuniverse space level. It turns out that the Sloan Great Wall is part of a much larger structure. 6 years before the discovery of the Sloan Great Wall, Maria Nesto identified 25 very rich superclusters out of a catalog of 220 within 1.6 billion light years. A side view of these 25 superclusters, in a side view, Nesto found that 16 are located in a disk-like region with a depth of just 450 million light years. These are shown as the solid black dots. He refers to this planar concentration as the dominant supercluster plane. And he also determines the probability of this arrangement of 16 superclusters occurring randomly is rejected at the 99% confidence level. But he doesn't offer an explanation for this disk-like concentration. A polar view of these 16 very rich superclusters plotted on the equatorial plane shows that the Sloan Great Wall is part of the dominant supercluster plane. The Vela and Virgo Gamma superclusters are parts of the Sloan Great Wall. So we've already established that the Sloan Great Wall is consistent with an 80-degree segment of the central core. So assuming this is so, an extension of the inner and outer boundaries of the Sloan Great Wall should contain a majority of the superclusters in the dominant supercluster plane. And this turns out to be true. 2/3 of the superclusters, or 11 out of 16, are contained within this ring. The odds of this occurring by accident are less than 1 in 1,000. The density of very rich superclusters in this ring is about twice the average density. So this ring of superclusters is consistent with the expected form, size, and density of the central core of the first outer space level. So this evidence refutes the expanding model. However, this evidence is consistent with the dynamic of gravitational revolution in the revolving model. So I mentioned previously tests for the reality of space expansion. And a review in 2014 was done by Martin Lopez Corregidora for 6 different types of tests. And this table here recapitulates his conclusions, his table of conclusions. And I've added a column to on the far right for the revolving static model. The only point I want to make with this slide is that unlike the expanding model or the static Euclidean model, the revolving model governed by absolute gravity is a good fit for all 6 tests. So the revolving model can explain what the expanding model explains and also what it cannot explain. The hypothesis of space expansion is effectively refuted by the overall results of tests for its reality. But in this day and age, a model must be derived from general relativity to be taken seriously. In 1949, Kurt Gödel found a static solution to the field equations for a rotating universe, which is consistent with the revolving universe. Gödel's model is a sphere of homogeneous matter, rotating with a constant angular velocity around a center. This matches the general description of the revolving model. The rotating model has an angular velocity constant that's determined by the mass density. The same applies in the revolving model, which has an angular velocity constant determined by the mass density. And the period of revolution in Gödel's model is 69 billion years, which is in reasonable agreement with the 84 billion year period calculated by the revolving model. And finally, absolute gravity provides an alternative explanation for the dynamics of the rotating model. So in Gödel's solution, Einstein's gravity appears to be equivalent to Newton's internal absolute gravity. That is, both can be compared to the force of elastic tension. So by equivalence, the revolving model can be derived apparently from Einstein's field equations. So the transition to the revolving model appears to involve a new understanding of the Hubble constant. The Hubble constant is defined by the critical density equation, which can be derived from both Einstein's gravity and Newton's. Equations of motion are dependent on the Hubble constant, which changes from a linear velocity constant in the expanding model to an angular velocity constant in the revolving model. So in this simple little cross-comparison list, the co-moving distance d of expanding space is replaced by the proper distance of static space. The 13.4 billion year old expanding universe is replaced by the revolving universe, which has a period of revolution of 84 billion years. The maximum radius of the expanding universe is 46.5 billion light years. The highest measured redshift for a galaxy, called HD1, establishes a minimum radius for the revolving universe of 178 billion light years. So the centerless and kind of unattractive expanding universe is replaced by a beautiful revolving universe with a center of gravity 9 million light years distance. The beauty of this model emerges in the truth that the center of absolute gravity is actually the location of the Isle of Paradise, the dwelling place of the Universal Father, the first source and center of all things and beings. There is a place of absolute spiritual value in the material universe, and this place is the ultimate destination of the mortal ascent to God. The discernment of supreme beauty is the discovery and integration of reality. The discernment of the divine goodness in the eternal truth, that is ultimate beauty. So what appears to be just a dense elliptical ring of galaxies is actually the superuniverse space level in the grand universe, which is the evolutionary domain of supreme deity. The grand universe is the threefold deity domain of the Trinity of Supremacy, God the Sevenfold, and the Supreme Being. The Supreme Being is the deity culmination of grand universe evolution, physical evolution around a spirit nucleus, and eventual dominance of the spirit nucleus over the encircling and whirling domains of physical evolution. Machiavellian Melchizedek tells us that the chief pursuit on the worlds of light and life is the quest for a better understanding and a fuller realization of the comprehensible elements of deity, truth, beauty, and goodness. In pursuing beauty, the inhabitants of these worlds become absorbed in the experiential study of cosmology. In the ideal, cosmology is the pursuit of the divine beauty discernible in God's material creation.
Thank you, George. It was a wonderful presentation, George, and we certainly have a great appreciation for your scholarship and very happy that you are publishing in recognized scientific journals. Gard, if you have a question that you'd like to go ahead and lead off with, please feel free.
My question revolves around the question of Albert Einstein. He says the most important question in his mind is, do we live in a friendly universe? And what you've just presented suggests, from a mathematical point of view, thinking about constants, thinking about order, thinking about unity, thinking about these various things from the angle of science, that indeed the answer to Einstein's question is unequivocally yes, which is really exciting. And again, I don't pretend to know any of the math or much of the math that you shared, but what I do know from Martin Rees, just six numbers, and the idea of constants is that we do live in an orderly universe and there is unity. So share with us some of your excitement in this journey toward understanding how the fit between the revelation and evolutionary science has emerged.
Yeah, it has been exciting because I believe I discovered things that relate to descriptions in the book. The first thing I believed, I still believe, I identified was the central core, what I'm calling the central core of the superuniverse space level. I mean, I first came across that on a whim. I just did a query of NASA's extragalactic database based on just a few ideas, and I saw this arrangement of data and go like, holy mackerel, there's something there. And it's been like that ever since. And I had to pretty much educate myself on all of the, well, as much as I'm able to, on the current thinking involving the Big Bang and so on and so forth. But no, I believe, as I said in my paper, that we're now at a point where the preconditions are in place for a paradigm shift in cosmologic thought. I mean, we have the theory from Kurt Gödel's rotating universe. That seems to indicate to me that someone soon will be able to come up with a theoretical explanation that would satisfy astrophysicists. And we have the data. The dominant super coaster plane and the ring of all of that. That's been discovered. That's there. The Sloan Great Wall. That's all there, and it's all too large to explain by the current theory.
Thanks, George. I'm going to voice Nigel's question. Nigel Nunn brings up the question of space respiration and how it relates to the revolving model. He says, we should also note that if master universe space has been expanding for the last 500 million years, then any galaxy within 300 million light years, that is within the Laniakea ring of superclusters, would naturally appear to participate in a local Hubble flow due simply to the existence of space. Nigel suggests the space expansion in the expanding model is real over the last 500 million years and can be explained by the expanding phase of space respiration. So, what is the relation between the expansion-contraction phase of space respiration and the revolving model?
Well, Nigel and I have had many discussions on this type of question. In my view, there are two causes of redshift. There's some sort of radial motion outward, and in the Urantia book it says, but the real motion occurs from rotation, from revolution. In other words, you remember that section in paper 12 where it says galaxies are not fleeing from us at the rates you think they're fleeing from us, that the rate of recession is not real. It's not real because it's caused by rotation, which is a motion perpendicular to us. So that, in my understanding, 95% of the redshift is caused by gravitational redshift, which means it's not caused by space respiration. However, there's 5% that is caused by respiration, the contraction and expansion of space respiration. So that's how I relate the two.
Okay, thank you, George. Phil, do you have a question?
How do you come to the conclusion that the space expansion of respiration in the expansion phase is only 5%? Because I was able to show that a 2.5% respiration during the expansion phase would contribute a significant amount of redshift, as all the matter in the peripheral space would be expanding 2.5%. Any two objects would be now 2.5% further away after a billion years, per billion years. So that turns out to be a significant expansion. Maybe it's because you've got more expansion due to the gravity, the absolute gravity cause that you propound.
No, in my model, almost all of the redshift is explained by gravitational time dilation, which doesn't require any motion. There's no motion. It's stationary. It's a static model.
Yeah.
The space respiration the 5% number is just a guess. In other words, if you look at the data that has been collected over the last half century relating, they've independently measured redshifts and distances. And they've said, if we put those two together, what do we get? We get the Hubble constant. And what the Hubble constant is it comes out as a rate of velocity, like 73 kilometers per second for every megaparsec of distance. So on all of these, if you take all of these different studies, and there have been hundreds, they all show redshifts between about 67 and 74 kilometers per second per megaparsec. And they all have errors associated with them. So I'm guessing. Now, in the revolving model, there isn't much room for leniency or for error, because it's just calculated it's a static situation that is calculated with the law of gravity, which gives the gravitational potential. So the differences that I'm talking about here, I think can be accounted for by space respiration. In other words, and I'm just using 5% as a guess, but it's something on that order is what I'm thinking of.
Okay, Phil, does that help?
It helps. I'll wait until David speaks or anybody else before I respond to that.
Okay. All right. Great. David, please ask your question.
All right. I'm not extremely scientific oriented, but I am curious to know how. I remember this slide about the overhead view, and they have I assume there's distances connected with each of those, dots on the slide. Yeah. Can you explain how they determine distance at that level?
Yeah, astronomic distances, there are literally dozens of different techniques that they use. The most obvious one is Cepheid variable stars, but that only it doesn't work out that far. But there are any number of others. The better known ones are supernova, type 1A supernovas, and other standard candles. And then they have something called the tip of the giant red branch. The list goes on and on and on. The most reliable distant measures, considered to be the most reliable, are the ones that are called standard candles, which would include Cepheids and type 1A supernovas and things like that. So that's how they determine the distances. And the redshift, they just simply measure off a spectrometer. It's just, they hook up something to the telescope and it says, that's the redshift.
But I imagine the Cepheids are not even visible after a certain distance. How far away are Cepheids
I think used? The most distant one they were able to measure was 75 million light years, I think, but don't hold me to that.
Okay. Thank you.
Yeah.
If Andre doesn't have a question, I'm going to go back to Phil.
Well, I do have a question. I'll be glad to pose it now. Thank you very much for that presentation, George. It's wonderful. I think it's breaking new ground what you are determining about absolute gravity. This, I mean, to anybody that thinks scientifically at all, and I'm not a scientist. I've taught some science, but I wouldn't pretend to be a scientist. But the idea that there could even be a way of proving through experimental observation that there could be absolute gravity is just wonderful. And I applaud you for your work on that in getting us to that. And then showing that the revolutionary constant model could be equivalent to the space expanding model. I apologize if I'm butchering the names. It's, I think that's also pioneering, and that's wonderful. How we get people to the persuasive element, the sales. Are there courses on selling your theory in graduate physics curricula? Probably not. Probably not. If there aren't, there probably ought to be how to deal with dogma among physicists and competing dogmas, because I know it's as prevalent there. All that, though, to say that there are a number of interesting things that you bring up, and I think that really needs to be somehow developed. Now, what's interesting is you've squared that up very nicely with the idea of paradise as a source of absolute gravity. And of course, there are those that will always want to go back to the idea that the scientific concepts as presented in the Urantia book are in need of revision, right? That those are the literal words that are always used, and they're taken all the way to the extreme that some of this has to be thrown out, to some of it needs to be rethought and derived in a new framework. Mm-hmm. So I want to give a shout out, first of all, to Tom Allen's The Great Debate on the Scale of Orvonton, because it comes directly to play with the question I'm going to ask you, which is tangential to some of what you've been talking about. And that is that there are so many there's about 7 competing ideas about how big Orvonton is. And for most of the readership, which may I call us lay readership when we're not at this scientific level, we derive some of our, our understanding, a lot of our understanding, based on what the book is saying. So I just want to get your take on, because your scales are talking millions of light years for, say, the transverse diameter of the superuniverse space level, for instance, would seem to be, according to one of those larger views of Orvonton in The Great Debate on the Scale of Orvonton. And yet we always have to go back to 32.211. And let me just read it, if you would allow me. The Satania system of inhabited worlds is far removed from Uversa, and that great sun cluster which functions as the physical or astronomic center of the 7th superuniverse. From Gerisum, the headquarters of Satania, it is over 200,000 light years to the physical center of the superuniverse of Orvonton, far, far away in the dense diameter of the Milky Way. Satania is on the periphery of the local universe, and Nebadon is now well out towards the edge of Orvonton. From the outermost system of inhabited worlds to the center of the superuniverse is a trifle less than 250,000 light years. Now that is orders of magnitude different, maybe 2, maybe 1, I don't know. I didn't catch all of your figures, but how then, obviously from a physicist standpoint, you're trying to argue from the empirical observable evidence down to how could that then fit with the model? As someone who taught mathematics, and I certainly don't have Phil's level of mathematics, but someone who taught, algebra, geometry, even a little bit of calculus, it coming from a strictly geometer's perspective, I would be looking at saying, well, Orvonton couldn't have a transverse diameter of more than about 500,000 light years. And if we go with the phrase that says, it's broader than it is thick, and it's much longer than it is broad, which is an interesting statement because it suggests a pickle-shaped Orvonton along that along that torus, we would be thinking about perhaps a 7 to 9 million light year circumference of what you call the kernel of the superuniverse space level. So my question would be, how do you square that with that statement of 32 to 11? And what is your reasoning behind that?
I can give you my justification, but let me just preface my remarks with a conclusion I reached a couple of decades ago, which is that you cannot analyze the Urantia, the text, the cosmological statements in the text as though they all fit together, because they don't. In other words, I think it's in paper 101 when it talks about, when you see an error on the superficial error on the face of the cosmologies herein presented, they're presenting cosmologies. In other words, they're not allowed, in my understanding, they're not allowed to say, well, we know which one is right, so we're only going to talk about that one. We're not going to give them new data, but we're only going to talk about the correct model. I think what they had to do, what they're required to do, is talk about all of the models, which included the galactocentric model, which was in the process of being superseded by the expanding model. And, it's hard to go back to 1934 when these statements were indicted and identify the various different cosmological models which had significant followings, but there were at least two: the galactocentric model and the expanding model. So, they make statements that are consistent and you can't come up with a consistent interpretation that logically connects all of the statements in the Urantia book about cosmology. That's my conclusion. So having reached that conclusion, I then decided I'm going to try to identify those things in the Urantia book which agree with current scientific knowledge, because our knowledge has changed. So at the time they said, in 1934, they said Urantian astronomers have already identified 8 of the major sectors of Orvonton. So I don't know. I looked at Edwin Hubble's 1936 book, The Realm of the Nebula, and that's where he identifies 9 galaxies that make up the local group. He was, so they obviously read his book. This is the way I think about it. They obviously read his book. They knew what he was going to put in his book. He was already talking about it in 1935 in his lectures at Yale. So, I mean, they already knew what he was going to put in. And, but that statement, they've already been identified. Well, what had been identified? A star? No, galaxies. Galaxies have been identified. Which galaxies? The 8 or 9 that Hubble identified as being definite members of the local group. What else could it be? It can't be galaxies far, far off, a billion light years away. Obviously, they all have to be connected to us. So knowing that, so that's my interpretation of that statement. And other people can have other interpretations. But with that interpretation, if it's the local group, then we know what the radius of the local group is. It's about 4 million light years. So that's my reasoning and how I got there.
Thank you, George. We have a question from Philippe Ott.
George, thank you for your marvelous presentation. As you know, I am dealing with quantum physics, and for me, gravitation is quantum gravitation, of course, and is about creation of mass. Actually, the mass is created in a discrete way, And this in turn is creating time, and together mass and time are creating space. So I wanted just to know what is your feeling about gravitation? What is gravitation for you?
It is an absolute gravity. It's an absolute presence circuit of deity. If you look in paper 12, okay, they tell you what it is. You know, Einstein said it propagates at the speed of light, and you know, people come up with all kinds of different ideas about how does it work. But you know, as soon as they say it's a presence circuit of deity functioning on an absolute level of reality, then we're to my point of view, we're limited to describing to the extent that we can how does it work. But we can't really get into what is it and how does it do what it does. We're talking about how does God do what he does, which is not a question that's really appropriate for science.
Thank you, George. This is very satisfactory for me. Of course, if I translate it in quantum physics, it is exactly what I think.
All right.
Okay. Thank you, Philippe, for your question. I think Phil has a follow-up, which I'm anxious to hear.
Well, thank you. And thanks, George. I've read your paper, or as much as I could understand of it, and followed along here. I think that the Urantia book says that absolute gravity really holds ultimatons together. Each one has paradise as its nucleus, and there's a spin rate for ultimatons. So it seems that paradise has a presence throughout. It's an elastic tension of paradise presence. No time between the action of paradise gravity, either linear or the absolute kind. So when you use the word time dilation, is that the kind of time dilation that results in two objects or two twins paradox, for instance? Would the twins that one who leaves and then comes back, would he really be a different age than his brother? I have a hard time with that idea. I know that most of the dilation is Doppler, and which would undo itself as you came together. You know, as you move away, if something recedes, the clock looks like it's slowed down as you look at it, because every instant it's further away, light has further to travel, and so the hands look like they're slow. But if it starts to move towards you, the hands start moving faster, according to your perspective. And I know Einstein said, well, they're not going to be exactly the same when they get together. I think that that's maybe his definition of simultaneity. I would quarrel with, but in any case, are you saying that it's the spreading out of time, or just the fact that gravity itself will deflect the light and therefore cause a slowing, effective slowing of the light that gets to us? Or is this really a time dilation in the relativity sense?
This is definitely time dilation in the relativity sense, and not in the sense of special relativity, but general relativity. I mean, as a very concrete example, we have satellites traveling around the Earth at 20,000 miles called global positioning satellites. and they have atomic clocks in them. And if they broadcast every second, they broadcast to us, a second has passed. When we receive it, we would see it was shorter than a second. In other words, if you put a clock up there and we set the clock here, atomic clock here to 12 o'clock, and set it up there to 12 o'clock, after a day, we say, what does your clock say? And up there on the satellite, they says, well, it says 12:01 the next day. It's been 24 hours and a minute. And we go, well, no, it's exactly 24 hours. Well, what happened? What happened was that's the opposite of time dilation due to gravitational potential can be called gravitational contraction. So time contracts up there. Instead of being 24 hours becomes shorter than 24 hours, which means it's no longer equal to 24 hours down here. Now, this doesn't get into the, moving things from here to there. This is just, this is measured. This is how the global positioning system works. If they didn't take account of time dilation, both from special relativity and general relativity, the positions calculated by the system would be off by 11 kilometers a day, or like a quarter of a mile per hour. So you have to take account of the time dilation factor in order for the GPS system to work.
I understand that. I've read that, and the question I have is how much of that is a Doppler, if any, effect? Because they don't bring those two clocks together and look at them here. They talk about them, and there's light, there's transfer. There's
virtually
they're in two different places, and they're going at different speeds.
Yeah, virtually none of it's Doppler. The component due to special relativity, which would be the Doppler component, is on these GPS satellites accounts for only, I forget, it was something like 5% or 10% of the total time dilation effect. So, it's all gravitational potential, it's almost entirely gravitational potential.
So that this would be a matter of this object has more energy relative to the Earth, and it's more massive. Does that mean that the hands are going around slower?
Essentially, the stronger the gravitational potential, the more time dilation there is.
Yeah.
So sitting here on Earth, time is more dilated than if we were sitting up in the International Space Station, where it's less dilated. You can say time contracts on the International Space Station. For people who are sitting on couches up there watching TV, it's different than it is down here. I mean, the difference is very difficult. We can't notice it as human beings, but it can be measured.
Thank you, George. I have to say we did deal with that in our hardware up on the space station when I was still involved in that. When we were sending data back and forth. So yeah, it is a real thing. Andre's got his hand up.
Maybe a question that a number of people are having are, of course, the Urantia book talks about space respiration, and that's different than I think what you've been referring to as space expansion. The Big Bang idea, which is really not corroborated in the Urantia book. The idea that matter is moving out through space, and that it's that movement of matter at various velocities further and further out that is causing the Doppler redshift, according to many current scientific theories. And you made a very good case for why that would be a relativistic phenomenon of time dilation. My question would be, how does that obviate space respiration's effect on also just moving objects out further from each other by virtue of the space itself actually expanding. In other words, why is it not space respiration that's causing the Doppler redshift? Or alternatively, why is it not a combined phenomenon?
First of all, it is a combined phenomenon. What I was saying before was that 95% of it is due to gravitational potential, causing gravitational time dilation, which causes gravitational redshift. That's 95% of it. The remaining small portion is due to space respiration in my concept. So you have a minor, they tell us that space respiration causes everything in the universe, everything, all the way out to the end of the fourth outer space level. Everything is moving out in a uniform manner, although they don't go into detail about exactly what they mean by uniform outward expansion. But nevertheless, in some sense, it's uniform. It's the whole thing. And then for contraction, you got the same thing in the opposite direction. So that is in many ways, I think, equivalent to the current concept of space expansion. The fundamental difference between what the Urantia book says, I believe, and modern science is they're saying space expansion is the whole thing. That's the whole explanation. Whereas that's not possible if the universe is revolving. So I believe in a revolving model of the universe, 95% of the redshift has to be due to gravitational potential, which means no motion, just potential. You sitting at your desk, you have a gravitational potential, even though you're not moving. And the same thing is true in the universe. So, so both types of redshift must be involved because they tell us the universe is expanding and contracting. It's just there's no concept of a revolving universe in the expanding model.
I'll just say that's a very new idea, probably in the minds of most readers. So a lot to cogitate on.
It is, yeah.
George, I have not seen, or I don't know of any corroboration in the Urantia book for time dilation. They do corroborate E equals mc squared. Can you point to, or in some sense, any place in the Urantia book that suggests time dilation exists?
Well, I mean, I could point to the evidence, but I was thinking about this because it was brought up some time ago. And, do you remember when Jesus was at the wedding in Cana and Mary came up and tempted him and he caused the wine to be produced? They call that a time miracle. In other words, it was just a natural process of making wine. It just was sped up. That's time contraction. And not only did that, I mean, assuming we take them at their word, not only did that happen, but they managed to take the product of that accelerated time and somehow transport it to this time. So I don't know. If you're going to press me, that's going to be my answer.
All right.
Okay. Great response, George. Thank you so much for your wonderful paper and the great discussion. We all want to give you great applause here. And this session is now concluded.
George, thank you very much.
Oh,
pleasure seeing you again, and
good seeing you.
Been looking forward to your explanations of the validity of absolute gravity. I think it's really groundbreaking.
Yeah, it was groundbreaking to me when I figured it out. So
wonderful.
Thanks.